under controlling microwave irradiation, and another is 1 dB catalyst microwave irradiation involving aromatic aldehyde resorcinol, malonitrile, and cyclohexanol. 1 ionic liquid catalyzed using ultrasonic radiation. It's also its drawback, involving aromatic aldehyde resorcinol, malonitrile, and cyclohexanol. Here our present work. In present work, we report that the DAPCO catalyzed 1-pot multi-component synthesis for pyranopyridine derivatives under the solvent precondition at room temperature. Yeah. We take that. We take here. Here we mention that in 10 mole percent DAPCO. Its reason is because we start from 1 mole percentage, but we can't get expected yields. That is, the yields are less, and the time required for this reaction is more. So we increase the 1 by 1. That is 1 mole percent, 2 mole percent, 3, 4, 5, up to 10. And after 10, yields are decreases, and time required is more. So we decided to take a 10 mole percent. This reaction is solvent free at room temperature. It is simple grinding, hand grinding. Its reaction is a simple hand grinding at room temperature. Here we take some aldehyde, and at laboratory level some aldehydes are available. So we use that aldehydes. Here some list of aldehydes, and we get this time in minutes. The time is less than 15 or 20. Here 15 or 10 minutes or 20, less than 15 minutes or 20 minutes. Here so here expected one. Here we accepted more. Here we get the more yields, that 74%, 80%, means up to more than 80%. In some cases 90%, 85%. Means we get expected yields that more than 80% or 85%. Experimental, a mixture of simple aromatic aldehyde, resorcinol, malonitrile, and cyclohexanol, which is grinded for the specific time with the DAPCO 5 mole percentage. Here I will mention that 5 mole percent at room temperature. The progress of reaction was monitored by TLC. We take TLC for the to monitoring the progress of reaction. After completion of reaction, the solid product which obtained, that is solid crude product, and the crude product was purified by the recrystallization method, simple recrystallization method using alcohol. The pure products were characterized by the IR just group and H1NMR. We take the H1NMR and IR. The MPs are took by the open capillary method and matched with that authentic samples. The melting points are took by the simple capillary method that are matched with the authentic samples, and also the yields are also matched to authentic sample and better than previous literature. Advantages of DAPCO. DAPCO is soluble in water. DAPCO is solid and easy to handle. DAPCO is economically cheap. It is no any instrument is required here. So that is a simple hand grinding process. Environmentally friendly condition are the merits of this work. The merits of this present work that is environmentally friendly means today the running concept is go green. So today the running concept is go green. For that, every student will decided to what my contribution to the go green. So eco-friendly condition at the merits of present work. Simple work the progresses. The required for the reaction, time required for reaction is very short. That is less than 10 or 15 minutes. Good to excellent yields. And the most important advantage of this work is we report the first time unsaturated aldehydes. We report the first time unsaturated aldehydes. From this present work, we conclude that the 1-pot multi-component coupling reaction between aromatic aldehyde, resorcinol, malonitrile, and cyclohexanol for synthesis of pyranopyridine derivative using DAPCO under solvent-free condition using grinding. The yield of product is good to excellent, and no side products could be detected on TLC. The yields of product are good to excellent. That means some previous work, the yields are less than 70% or 60%. In our present work, we get more than 80% yields, and no any side product could be detected on TLC. Here some references we were used. Our college has a facility library, and then in that library we have the facility in FlipNet, and some references from we took these references. And at last acknowledgement, I will thank to Principal Padmashri, Dr. Vithalrao, Vikhe Patil College, PUP College, and for providing the necessary laboratory facilities. We thank to Dr. S. Pandit, our project guide. We thankful to Safe Punjab University Chandigarh for the spectral analysis. And last I will thank to organizer committee for giving me opportunity to present here, Margaret. And thank you all.
Thank you. Any questions from the participants? Okay, thank you, Akash.
Thank you.
For the next oral presentation, I invite Mr. Abhijit Somonchi. Mr. Abhijit Somonchi.
Good morning, all of you. My name is Abhijit Somonchi. Today, my seminar topic is lanthanum chloride efficient catalyst for one-pot multi-component synthesis of one-pot polyhydroquinone derivatives through asymmetrical Hans reaction. There is a multi-component reaction in one pot, so two or more reactants by using two or more reactants, and then give one product in one pot, that is in RP condenser. Why we choose the lanthanum chloride catalyst? That's properties and uses of that's mentioned here. The lanthanum chloride is an inorganic compound. It is common salt, but it is used in research, biochemical research. That lanthanum chloride is quite solid, soluble in water and alcohol also. It is white, odorless, and hygroscopic powder. The lanthanum chloride is used in swimming pools to prevent algae growth. It is also used in the biochemical research. The doped with cerium, it is used as scintillator material in organic synthesis. It is used as Lewis acid. Lanthanum chloride is used as catalyst in organic synthesis, and it is used as a gamma detector. So all that's uses and properties of that lanthanum chloride. Then why we contain that one-pot polyhydroquinone derivative, that's it is considerable interest due to the medicinal and biological applications, such as it is neuroprotectant and platelet anti-aggregatory activity. It is chemosensitizer in tumor therapy. You know that's chemosensitizer. It is a drug that's are used in the tumor therapy for the preparation of the tumor cells. It is used as a drug for treatment of congestive heart failure. It is used as anti-malarial, anti-inflammatory agent, anti-asthmatic agent, antibacterial agent, anti-diabetic agent, antimicrobial agent, antioxidant agent, anti-ulcer agent. It is used as tyrosine kinase inhibiting agent. It is used as calcium channel blockers for the treatment of cardiovascular diseases, etc. Those are the uses and the applications of that one-pot polyhydroquinone derivatives. In previous work done or literature survey, those are the methods have been reported for the synthesis of one-pot polyhydroquinone derivatives by the different ways, by using various catalysts and techniques. The catalysts and techniques are very costly, or they are required more time, and then I try to that's reaction time is minimized. So in the some of the catalyst is a costly one, and this technique are there. For example, conventional heating or refluxing, that's take more time for the preparation of one-pot polyhydroquinone derivative. And then I will try to that's reaction time is minimized. So some of the techniques are very cost. That is ultrasound or ionic liquids or microwave irradiation. These are the techniques are costly. So in my reaction, simply room temperature that will the next present work. In my present work, we reports the catalytic role of lanthanum chloride for one-pot multi-component reaction, that is the synthesis of one-pot polyhydroquinone derivatives through unsymmetrical Hans reaction. That is the multi-component reaction. The aldehydes, ethyl acetate, diamidon, ammonium acetates in lanthanum chloride at 5 mole percent in ethanol at room temperature. The all mixtures are mixed together and then found the 1,4 polyalkyl derivative, that is one product, no other products are detected. Then time is very minimum in this previous work done. They take more time, that is 3 to 4 hours, and I'm trying to that reaction time is minimized in 15 to 19 minutes, and yield are also good to excellent. I will use that number of aldehydes like electron donating, electron withdrawing, unsaturated aldehydes, and also heterocyclic aldehydes. We firstly reported their unsaturated aldehydes like cinemaldehydes or heterocyclic aldehydes like phosphoraldehyde. In previous work done, they are not reported there. So we first reported that unsaturated aldehydes. That is the pinpoint of my work. That is the advantages of my present work. It is good to excellent yields, easier work process, shorter reaction time, mild reaction condition, no desired side product could be detected. That is the main point of my work. The last one, it is also important, the environmentally friendly conditions. Those are the advantages of this. Experimental in the round bottom class, we take aldehyde, aromatic aldehydes, ethyl acetate, diamidon, ammonium acetate. In ethanol was stirred at room temperature with lanthanum chloride, 5 mole percent. We take 1 to 10 mole percent lanthanum chloride, but I will firstly choose the 5 mole percent because after the 5 mole percent, that's yield are decreased, so they are required more reaction time. Or before 5 mole percent, they are yield are increases, and then after 5 mole percent, they are decreases. So I will choose the 5 mole percent catalyst, that's lanthanum chloride. Then the progress of reaction was monitored by TLC. After completion of reaction, the solid product was obtained. After filtration of crude product was purified by recrystallization by using alcohol. The pure products were characterized by IR and H1NMR. The melting points are took by open capillary method and matched with authentic samples. And then last conclusion, we have reported a simple catalytic method for the synthesis of 1,4 polyalkyl derivatives through by one-pot condensation reaction between aromatic aldehydes, beta-keto esters, diamidon, and ammonium acetate. That is a nitrogen donating group that's using lanthanum chloride and efficient and green catalyst. And then main sentence that environmentally friendly conditions are the merits of the present work. Those are references are used for the preparation of 1,4 polyalkyl derivatives. This tetrahedral letters, singlet, green chemistry. Those are the references are to buy in library. Implement services are available from there. Those references are taken and the work is acknowledgement. We are thankful to Principal Padmashri Vikhe Patil College for the providing necessary laboratory facilities. We are also proudly thankful to Dr. S.S. Pandit sir, our project guide. We are thankful to SAFE, Punjab University, Chandigarh for spectral analysis. We are also thankful to organizer of the national level conference for giving me opportunity to present work. Thanks.
Thank you.
Yeah, actually, I have a small doubt.
Yes.
How you people are calculating the yield of a particular reaction? What are the procedure that you are following? Because in sometimes telling that the yield is more than 90%, 95% like this.
Yes.
How we can get that much of yield in case of an organic reaction? That's also you are constructing a system of fused rings in this one. How you can get that much of yield above 90%, 95% in some cases? It's very difficult actually because the reaction is always you are using one inorganic material only as the catalyst.
Yes.
But how you are calculating this yield?
That's the carbon values and those molecular Yeah.
Okay, you think about it.
Yes.
You're going to follow a systematic procedure for the calculation of the yield.
Yes.
So if your yield is more than 95%, if you submit your research article to a particular paper of having some international reputation, then they will ask you some of the details about your calculation, the procedure followed by your calculator. You be careful about this.
Yes.
While reporting the yield.
Yes.
You say, oh, okay.
Yes.
So try to follow a systematic procedure.
Yes.
Okay.
Okay, thank you, Akash. Abhijit. For the next hour presentation, I invite Dr. V.R. Purath.
Shubh Sakal, good morning. My name is Day-2-Session-1-Oral, Ismail Yusuf College, Mumbai. Initially, I thanks the organizer to give me an opportunity to express my view related to the basic pharma core, which will be designed. The topic my presentation मराठीतून बोललं चालेल कारण बरेचसे विद्यार्थी आहेत तर स्ट्रक्चर activity relationship synthesis molecular docking and anti-TB study. बेसिकली आपण जेव्हा लॅब मध्ये एखादी गोष्ट काम करतो, this is my abstract, go to the next, this is my presentation points. जेव्हा आपण एखादी गोष्ट आता लॅबोरेटरी मध्ये काम करतो तर आपण एखादी रिएक्शन डिझाइन करतो आणि सिंथेसिस करतो आणि नंतर ऍप्लिकेशनचा स्टडी करतो. बट नाउ डेज आता तसं राहिलेलं नाही. कॉम्प्युटरचा जमाना आहे. बरेचसे सॉफ्टवेअर तुम्हाला अवेलेबल आहे. काही पेएबल असतात, काही फ्री असतात. कॉलेज लेवलला बरेचसे सॉफ्टवेअर फ्री मिळतात आणि फ्री सॉफ्टवेअरचा सिंथेसिस किंवा एखादा रिसर्च करण्यासाठी ऑर्गॅनिक केमिस्ट्रीसाठी तो वापर कसा करावा, दॅट इज माय एम टू प्रेझेंट हिअर. पहिला पार्ट आहे स्टडी ऑफ द मॉलिक्युलर प्रॉपर्टीज. दिस इज ॲब्स्ट्रॅक्ट. केमड्रा नावाचं सॉफ्टवेअर आहे जे तुम्हाला फ्री ऑफ कॉस्ट मिळतं आणि केमड्रा 70 नावाचं सॉफ्टवेअर आहे जे तुम्हाला ट्रायल साठी मिळतं 15 दिवसासाठी. तर एखादा मॉलिक्यूल तुम्ही डिझाइन केला आणि तुम्हाला त्याचं सिंथेसिस करायचं असेल तर तुम्ही केमड्रा मध्ये टाका. त्याच्या सगळ्या इलेक्ट्रॉनिक अँड मॉलिक्युलर प्रॉपर्टीज ते सांगतं. दॅट इज द कॅल्क्युलेटेड बाय द सॉफ्टवेअर. त्याच्यामध्ये एरर असू शकते पण एक आयडिया आपल्याला मिळते की मी जो मॉलिक्यूल बनवणार आहे त्याच्या ऍक्च्युअल प्रॉपर्टीज काय, त्याच्या चार्जेस कसे असतील, बॉन्ड लेंथ कशा असतील, स्टिरिओ केमिस्ट्री काय असेल, बॉन्ड अँगल काय असेल, त्याचं व्हॉल्यूम किती असेल, डेन्सिटी अंदाजे किती येऊ शकेल, पार्शियल प्रेशर्स किती येऊ शकेल जर डेन्सिटी वेपराइज केला तर त्या सगळ्या प्रॉपर्टीज आपल्याला मिळू शकतात बाय युजिंग द सॉफ्टवेअर. जर आपल्याकडे लॅपटॉप असेल आणि आपण जर ते लॅपटॉप मध्ये मॉलिक्यूल टाकला की दॅट इज विल बी द लिंक. ह्या प्रॉपर्टीज आहेत ज्या आपण डिटरमाइन करू शकतो बाय फ्री ऑफ कॉस्ट, 1 रुपयाही न देता. त्यानंतर सॉफ्टवेअर आहे दॅट इज द पेएबल. इन माय कॉलेज फॅसिलिटी इज देअर. डेन्सिटी फंक्शन थिअरी हे त्याचं मटेरियल स्टुडिओ म्हणून डेन्सिटी फंक्शन थिअरी त्याचा बेसिक आहे. त्याच्यामधून आयडिया मिळते की याचे मोनो काय असेल, नोमो काय असेल, त्याचे अरेंजमेंट काय असेल आणि केमिस्ट्रीसाठी आयडिया आहे की व्हॉट इज द बँड गॅप, मॉलिक्यूलची बँड गॅप काय असेल, त्याचं ऑर्बिटल ओव्हरलॅपिंग कसं असेल, दॅट विल बी द कॅल्क्युलेशन विंडो. चार्जेस काय असतील अगर हेटेरो ॲटम आहे, कारण कोणत्याही मॉलिक्यूलची जर बायोलॉजिकल प्रॉपर्टीज आपण स्टडी करायची ठरवली तर त्याच्या आयटम्स वरचे चार्जेस, त्याची चार्ज डेन्सिटी, त्याचा इंटरॅक्शन दुसऱ्या बरोबर कसं होईल ते चार्जेस वरून ठरवलं जातं. म्हणून तेही महत्त्वाचं आहे. इट विल बी कॅल्क्युलेटेड बाय युजिंग द कॉम्प्युटर विदाउट गोइंग इनटू द लॅबोरेटरी. हे एक सॉफ्टवेअर आहे फोर्ज. जर तुम्ही रिसेट नावाची कंपनी आहे आणि जर तुम्हाला काम करायचं असेल केमड्रॉप त्याचा इंटरनल स्ट्रक्चर देतं, फोर्स सॉफ्टवेअर आहे त्याच्या एक्सटर्नल प्रॉपर्टीज, म्हणजे जर हा मॉलिक्यूल इथे ठेवला आणि त्याच्या आउटर कोणत्या साइडला पॉझिटिव्ह चार्ज डेन्सिटी असेल, कोणत्या साइडला निगेटिव्ह चार्ज डेन्सिटी असेल, कोणत्या साइडला वॉटरची त्याच्या बरोबर इंटरॅक्शन होऊ शकेल, कोणत्या साइडला हायड्रोफोबिक हायड्रोफिलिक कॅरेक्टर असेल. जर एखादा रिसर्च करायचा असेल आणि लॅबोरेटरी मध्ये जाऊन केमिकल रिएक्शन करणे अगोदर जर आपण ह्या गोष्टीचा अभ्यास केला, so we have got an idea about the molecule and their structure. This course software तुम्हाला free of cost मिळतं. Go to the research company's website and apply it. तुम्ही त्यांना एक मेल पाठवा, ते तुम्हाला 1.5 महिन्यासाठी ट्रायल म्हणून टोटल सॉफ्टवेअर देतात आणि त्या मॉलिक्यूलचा तुम्ही स्टडी करू शकता. याचं महत्व काय मी तुम्हाला नंतर सांगेन. तर दिस वन विल बी गिव्स यू कोणत्या साइडला पॉझिटिव्ह चार्ज असेल. इट इज यूज्ड टू स्टडी द स्ट्रक्चर ऍक्टिव्हिटी रिलेशनशिप. आपल्याला माहिती की एखादा ड्रग असेल आणि तो एखाद्या डिसीज बरोबर डिसीज साठी ट्रीटमेंट साठी वापरतो. आपला एम आता माय एम इज अन ट्युबरक्युलोसिस. तर ट्युबरक्युलोसिस साठी आयसोनियाझाइड नावाचं सेलिकॉक्झिन हे ड्रग्स वापरतात. त्याचं स्ट्रक्चर मला माहित आहे. त्या नोन ड्रगच्या मॉलिक्युलर प्रॉपर्टीज काय आहे, त्या मॉलिक्युलर प्रॉपर्टीजची जर मी एखादा मॉलिक्यूल डिझाइन केला आणि सेम मॉलिक्युलर प्रॉपर्टीज जर ते दाखवू शकत असेल तर देन वी गो टू द लॅब अँड सिंथेसिस. हे त्याचं ऍप्लिकेशन आहे म्हणून हे सॉफ्टवेअर वापरलं जातं. दिस वन विल बी द स्ट्रक्चर ऍक्टिव्हिटी रिलेशनशिप ऍप्लिकेशन. फोर सॉफ्टवेअर आहे. जर करायचं असेल रिसर्च गो टू द रिसर्च कंपनी सॉफ्टवेअर अप्लाय. देन दे हॅव बीन गिवन यू training as well as the free software for 2 months. Then these are the images. The software images that the isoniazid is a drug which will be used for the treatment of TB, and my will be the benzofuran hydrazide, and that is a basic pharmacore I have been taken. That is not actually doing. I am not doing actually work on this one. We have been go the substitution pattern. पण सबस्टिट्यूशन पॅटर्नच्या अगोदर बेसिक मॉलिक्युल आपल्याला डिझाइन करावं लागते आणि दॅट इज विल बी द रिलेशनशिप. जर यांचं एक्सटर्नल प्रॉपर्टीज मॅच केल्या नॉन ड्रग्सची मी बनवलेल्या मॉलिक्युलच्या बेसिक फॉर्मवर आय हॅव बीन फाउंड 74% मॅच. देन मॉलिक्युलर डॉकिंग. तर याचेही बरेचसे सॉफ्टवेअर फ्री ऑनलाइन आहे. जेमोल आहे. आणखी स्कॉडेंजर नावाचं सॉफ्टवेअर आहे. जर एखाद्याला पीएचडी करायची असेल आणि त्याला जर काम करायचं असेल तर गो टू द स्कॉडेंजर कंपनी सॉफ्टवेअरची वेबसाईट आहे. रजिस्टर देव, मेल देव, ते तुम्हाला एक सॉफ्टवेअर देतं स्कॉडेंजर सॉफ्टवेअर अँड दॅट विल बी गिव्ह अ ट्रेनिंग. हे सॉफ्टवेअर कसं वापरायचं आणि 2 ते 2.5 महिन्याचं फ्री पूर्ण सॉफ्टवेअर पॅकेज तुम्हाला दिलं जातं. देन इफ यू इंटरेस्टेड यू हॅव बीन डू द वर्क. याचं ऍप्लिकेशन काय दॅट इज द स्कॉडेंजर. तर हे सगळे प्रोटीन डाटाबेस ऑनलाइन फ्री ऑफ कॉस्ट अवेलेबल असतात. त्या सॉफ्टवेअरचा वापर अशा पद्धतीने केला जातो. देअर विल बी द फर्स्ट लिंक येते तुम्हाला तिथे कोणता प्रोटीन. तर आपण एक ह्युमन प्रोटीन बॅक्टेरियल प्रोटीन ऑनलाइन अवेलेबल आहे फ्री ऑफ कॉस्ट. तर तुम्ही सॉफ्टवेअर मध्ये फक्त तो प्रोटीन पहिल्यांदा आपण सिलेक्ट करायचं की तुम्हाला इन व्हायव्हो काम करायचं आहे. नंतर सिंथेसिस नंतर इन विट्रो करायचं आहे. सेलच्या आत करायचं, सेलच्या बाहेर की सेल मध्ये काम करायचं. त्यानुसार तुम्ही तो प्रोटीन सिलेक्ट करा. ते पीडीबी अवेलेबल आहे. तो प्रोटीन रिपेअर करा. म्हणजे तो रिपेअर नसतो क्रिस्टलाइन स्ट्रक्चर साठी त्याच्यात वॉटर वगैरे टाकायला असतं. काही ठिकाणी हायड्रोजन नसतात. तो रिपेअर करा. रिपेअर केल्यानंतर सॉफ्टवेअर मध्ये टाका. सॉफ्टवेअर सांगतं की याच्या कोणत्या कोणत्या ठिकाणी बाइंडिंग साइट्स आहेत. तर बाइंडिंग साइट सिलेक्ट करा. बाइंडिंग साइटचा डाटा येतो दॅट इज द साइट स्कोर. आपल्या मॉलिक्युलचा आपण स्टडी केलेला असतो की याच्या साइटला निगेटिव्ह चार्जेस जास्त आहे. माझ्या मॉलिक्युल वरती हायड्रोजन डोनर जास्त आहे किंवा हायड्रोजन ऍक्सेप्टर जास्त आहे. त्यानुसार तुम्हाला एकदा साइट स्कोर नुसार तुम्ही डॉकिंग साइट सिलेक्ट करू शकता जिथे तुमचा मॉलिक्युल अटॅक होऊ शकतो किंवा त्या साइटचा हायड्रोफोबिक नेचर तुमच्या मॉलिक्युलचं जास्त असेल तर ते तुम्ही बेसिक पकडा. हायड्रोफिलिक नेचर जास्त असेल तर तो बेसिक तुम्ही पकडू शकता. जर त्या दोघांचं बॅलन्स नसेल तर तो बॅलन्स पॉइंट घ्या. डोनर ऍक्सेप्ट कर, तुमच्या मॉलिक्युल वरती जास्त डोनर ऍटम आहे, हायड्रोजन डोनर करणारे, हायड्रोजन बॉन्डिंग मध्ये डोनर पार्ट वाले, हायड्रोजन बॉन्डिंग मध्ये ऍक्सेप्टिंग पार्ट मध्ये जास्त असेल, त्या प्रकारे तुम्ही डॉकिंग साइट सिलेक्ट करा. and you have been draw the structure. The software will be make it stabilize, त्याला minimum stabilize energy साठी लिंक असते, you put there, त्याची stereochemistry, त्याचे अरेंजमेंट आपोआप ऍडजस्ट होते. and if you dock it, you have been obtain the results. ते सॉफ्टवेअर तुम्हाला रिझल्ट देतं की तुमच्या मॉलिक्युल्स किती पर्सेंट डॉक होऊ शकतात. इट कॅन बी एक्सप्लेन बाय दिस वन डॉकिंग स्कोर. जर हा डॉकिंग स्कोर असं मानलं जातं, दॅट इज इंटरनॅशनली ऍक्सेप्टेड, की असं मानलं जातं डॉकिंग स्कोर 7 पेक्षा जास्त आला तर इट विल बी द गुड. जर 7 पेक्षा जर तो कमी येत असेल तर यू शुड बी रिवाइज युअर वर्क. तर दिस वन विल बी द प्रॉपर्टीज आपल्याला मिळू शकतात. The docking score will be the important. Then these are the images, 3-dimensional images आपल्याला मिळतात सॉफ्टवेअर मध्ये की मॉलिक्युल्स डॉक झालेला आहे, त्यामध्ये तो कशा पद्धतीने फिट होतो, कोणते इंटरॅक्शन्स तो त्या प्रोटीन बरोबर दाखवतो. आणि these images मध्ये तुम्हाला ते रेड, ब्लू, ग्रीन हे मिळतात. एक तर तुमचा तिथे इलेक्ट्रोफिलिक कॅरेक्टर तयार होत असेल, न्यूक्लियोफिलिक तयार होत असेल, हायड्रोफोबिक तयार होत असेल, तर त्या पद्धतीने तिथे कलर्स येतात and you have been use it. Then हे सगळं कशासाठी करायचं, तर आपण एखाद्या केमिकल लॅबोरेटरी मध्ये जातो आणि आधी मॉलिक्युल्स बनवतो आणि नंतर बायोलॉजिकल स्टडी करतो. बायोलॉजिकल स्टडी केल्यानंतर आपल्याला असं कळतं की माझ्या मॉलिक्युल्स ऍक्टिव्हच नाही, आणि असेल तर खूप कमी ऍक्टिव्हिटी दाखवतो. and that is the waste of your resources and time. हे सगळं अवॉइड करण्यासाठी you should be take the help of computer. आणि बऱ्याचशा फार्मास्युटिकल कंपनीमध्ये अशा पद्धतीचं R&D मध्ये काम होतं. आपण ही टेक्नॉलॉजी ऍक्सेप्ट करायला पाहिजे. तर माझा एम आहे की I have been aim only this one की आपण familiar आहोत सगळे कॉम्प्युटर्स, तर you should be use that. This one will be the basic known literature आहे. Actually this procedure will be known. I have been not use that procedure as good because those procedure I have been used that will be file a patent, disclose करू शकत नाही. That will be the room temperature synthesis. Known literature procedure आहे, single step synthesis आहे. These are the spectral analysis data, IR and NMR. Then this one will be the MB assay. We have been to blue assay, anti-tuberculosis against the H37 RB strain. We have been found that our docking score isoniazide बरोबर कंपेअर केला तर 74% आहे स्ट्रक्चर ऍक्टिव्हिटी रिलेशनशिप. आणि त्यानुसार वी एक्सपेक्ट 95 पेक्षा जास्त जर तुमचा स्ट्रक्चर ऍक्टिव्हिटी रिलेशनशिप स्कोर आला तर आम्ही एक मॉलिक्यूल पण बनवला, 90 पेक्षा जास्त आला तर त्याची ऍक्टिव्हिटी कंपॅरेबल टू द ड्रग येते. 90 पेक्षा जास्त आम्हाला 74 आहे, तर that will be requirement of drug will be 3.7 microgram per ml, and our basic molecule will be shows activity at 50 microgram per ml. That will be we have been checked and we reject the samples. Conclusion will be this one. If you want to do the research, then highlight the importance of the research for the society. If you want to do the biological activity, you should highlight the research for that way. This one will be the application part. Molecular modeling and docking study will be reduce the efforts, chemical pollution in the finding of active pharmaceutical ingredients. Then this one will be the more goal center and reduce the time required, and the application of the different software tools for the calculation of various physicochemical properties successfully correlated with practical observation. So once you design the basic pharmacore, there will be the substitution position, And this software having a provision जर बेन्झोफिरॉन असेल, माझा बेन्झोफिरॉन आहे 3 आणि बेन्झीनच्या 4 अशा 5 कार्बन फ्री आहे. तर त्या सॉफ्टवेअर मध्ये तुम्ही फक्त सबस्टिट्यूएंटची लिस्ट टाइप करा, ते सॉफ्टवेअर स्वतःहून सबस्टिट्यूएंट या सगळ्या पोझिशन मध्ये टाकतात आणि एकाच वेळेस तुम्हाला हजारो मॉलिक्युल्स मिळतात आणि ते ऑटोमॅटिकली स्ट्रक्चर ऍक्टिव्हिटी रिलेशनशिप दाखवतात आणि इथे आपण घेऊ द बेस्ट मॉलिक्यूल की जो सर्वात चांगला स्कोर, सगळ्यात चांगली स्ट्रक्चर ऍक्टिव्हिटी रिलेशनशिप आहे असा मॉलिक्यूल आपल्याला मिळतो आणि तो मॉलिक्यूल आपण जर सिंथेसिस केला and we have been do the actual biological study, so we have been found. I have been designed 5 molecules and they shows the minimum concentration than the novel drugs. So this one will be the applicable for me in research and I hope you people also do the same before going into the laboratory. If you apply these tools in the research, that will be the benefit to the society. Once again, I thanks to the organizer to give me an opportunity and thanks to my principal and the government of Maharashtra. They have been provided me fund and laboratory facility. Thank you.
Thank you, sir.
Any question? Thank you.
Thank you, sir. Now moving on towards the first technical session of the day, which is based on lignosulfonates, materials and properties. The chair for this session will be Professor P.M. Bhosle, sir, and I request him to chair the session. Now let us have the pleasure of listening to the great knowledgeable speaker, respected Dr. K.V. Pai, sir, from the Department of Industrial Chemistry, Coimbatore University, Shimoga. Before that, I invite Professor K.R. Kadam to introduce respected Dr. K.V. Pai, sir.
First of all, on behalf of Padmashri Vikhe Patil College and Department of Chemistry, I welcome all the guests present with us who valued our invitation and graced their presence for the 2-day national seminar on emerging trends in chemical sciences. Honorable speaker of the session, Professor Vasant Kumar Pai sir, respected chair of the session, Dr. Professor P.M. Bhosle sir, all the delegates and participants from various colleges and universities, my colleagues and dear students. It is a matter of pleasure to put a brief introduction in front of you of a great personality, Professor K. Vasant Kumar Pai, our today's first plenary speaker. Professor Pai sir is from Kuvempu University, Shimago, situated in Karnataka state. The place is about 1200 kilometers away from Pravara. He is much fond of in delivering lectures and keep the student learning through. Only that thing made he to bear such a long hectic journey for about 20 hours and to be with us. Professor Pai sir has 28 years of rich experience in teaching as well as research. After completion of his PhD, he has joined Kuvempu University 28 years ago as a lecturer. Presently, he is working as a professor in industrial chemistry in the same department. He is an eminent scientist and has great interest in research and innovation. He used to spend most of his time in laboratory with his students, as a result of which he has more than 100 research publications with good impacts on his credit in the journals of international repute. More than 20 students completed their doctoral research and 4 students completed their MPhil under his valued guidance. Presently, 8 students are working under his research umbrella. As I mentioned earlier, he is much fond of in delivering lectures, as a result of which he is a visiting faculty at a number of universities in Karnataka, Andhra Pradesh and Maharashtra. He has delivered more than 30 high-level lectures in different training programs, university teachers, sponsored by DST and Government of Karnataka. He has conducted more than 300 training programs for the students preparing for competitive examination like UPSC, Karnataka Public Service Commission, etc. He is the author of 4 books, those he wrote for his university students. So it's a beautiful moment that Paisar is with us to share his views on emerging trends in chemical sciences. With these words, I conclude my brief introduction. Thank you. Thanks a lot.
So, Shubh Sakar and Suprabhat. Thank you very much, sir, for your introduction. But you have to excuse me, I'm not in a position to speak in Marathi. I can understand Marathi because of the contact of the people of Kolhapur. Today I'm very happy because Professor Bonsle is sitting in the chair. He's my very close friend. That's why I put him. Now, in the beginning, I want to tell you one small thing. Why I have selected this particular topic for the presentation. The topic is lignosulfonates. Basically, I'm a student of industrial chemistry. I'm interested in the industrial and commercial applications of certain materials which can be used for the purpose of one particular community. In India, thousands of industries are there. Which are using natural resources. Means we can call those resources as renewable resources. Some industries, example of these industries are textile industry and paper and pulp industry. So many industries are there. Some industries are extracting non-edible oils from natural resources. But unfortunately, in India, we are getting some end products in addition to the main products. We are using the end points of those industries for the purpose of fueling or for the purpose of getting some fuel or for the purpose of getting the heat energy. We are using this as fuels, or we are simply discarding it to the atmosphere as the waste. We have to learn so many things from people of China. The political relationship between China and India is not so good, even though we have to learn so many things from China. The people of China are not wasting even a single grain. They are converting it into something and they are exporting it to some other country in the form of some usable materials. I don't worry about the quality. I want to argue, China is famous for leather industries. We are using many Chinese material prepared with the help of the leather. Believe me or not, last month one of my students was working in, he came back from China, he was working in that particular place for about 4 years. Do you know what the raw material they are using for the purpose of the preparation of your leather goods such as your belt, pocket, etc., etc.? The skin of stray dogs. Okay, let it be. Similarly, China is one of the biggest manufacturer of paper and textile. And in that particular industry, they are getting large quantity of lignosulfonates. Lignosulfonate is not the end product of this paper industry. They are getting large quantity of lignosulfonates. In India, again, we are throwing the product lignosulfonate into the atmosphere. We are simply discarding it to the environment as the waste, or we are simply burning it. But the Chinese people are converting the lignosulfonate to some useful material and they are exporting this to the different parts of the world, and they are gaining so much of commercial benefit from that particular export. So here in India, there are wonderful opportunities where we can convert these waste products or byproducts of any industry to a useful one. Now, how we can, give a minute. Actually, this is the beautiful photograph, of our campus. The area of this campus is popularly known as Sahel area. This is the extension of the Sahel area of Maharashtra itself, and it is located in the central Karnataka. This once upon a time, this place was famous for thick forest, and a small part of that forest was at the time known as Dandakaranya. About 12 kilometers away from our university campus, one beautiful industry was there. Particularly, I am using this past tense, like I will tell you shortly. One industry was there, Mysore paper mill, completely owned by government of Karnataka, and it was famous for high quality paper. It was producing large quantity of paper of very high quality. So we were providing a consultancy service to that particular industry, especially the field of analytical chemistry. And at the time, Dr. Vithalrao, basically the person is from Karad of Maharashtra. He was working there as deputy general manager. He was having very good experience. He advised us to start some work with using these lignosulfonates. It is produced in the large quantity at the Mysore paper mills. Then we have started our work using this lignosulfonate for the production of many useful products. I will tell you what are those shortly after this one. Up to 1914, about these 12 years are known as the golden period in my career, because in that period 6 students undergraduates were able to produce PhD thesis, and 3 of those are now working in France in one of the important paper and pulp industry. And in that period, we were able to publish nearly 50 papers. That's also wonderful journals of very high reputation. But in 2014, that industry was stopped because of some unknown reasons. The reason was not associated with the environmental problem. The economic crisis or financial problem was not the actual reason for the closure of that particular industry. But I don't explain the actual cause for the closure. If I use the word, or if I associate the word local politics with that particular problem, then every Indian will be able to understand the actual cause lying behind the closure of that particular industry. Now it is stopped now. It is not working. It is not functioning. The total capital invested by government of Karnataka for that particular industry was more than 12,000 crore rupees. Nearly 10,000 people were working there as the employees. They were all reserved from their position. Now the industry is not functioning. Now it is closed now. But okay, let it be. What is lignosulfonate? I have to tell you. I have to give some information to you. Okay, look at this beautiful picture. You know, there is the name of T.S. Eliot, one of the famous celebrated English poets. In one of his poems, he uses the word, "Think of beauty is a joy forever." The same statement is also mentioned in one of the Upanishads of India, Satyam Shivam Sundaram. Anything which is beautiful must be divine, and it must be real. Any art in the reverse direction also. Any beautiful thing must be divine, and what is this real? That's the statement. Now look at this. This is the cross-section view of a tree, well-grown tree. You can see some beautiful rings here, beautiful rings, and from these rings you can collect thousands of information about the environmental and meteorological and geographic history of that particular place. Now these rings are developed in 1 year, every year. The tree has the capacity to develop one ring around its center, around its center. This is the source of information to the
students of botany, no doubt about this. But believe me, even the students of environmental science, even the students of meteorology, geography, cosmic physics, and chemistry are getting some information from this. Now, here, how the information stored here is useful for the students of cosmic physics. I will tell you what happens. Earth rotates around the axis, around its axis, around the sun in a period of 1 year. Is it not? Similarly, sun also rotates around its own axis, in a period of 11 years. What happens in every 11 years? Some spots on the sun directed towards the earth. Means these spots are having its own impact on the magnetic field of the earth. Now, here, these plants are having the capacity to store the impact of the change in the magnetic field on their different positions. This is one thing. And you can observe one more important thing here. Some rings are thin, some rings are thick. Now, usually in meteorology, we can classify the season into different categories. One particular year which receives sufficient amount of rain, that particular region, that particular season is generally known as the wet year. And if the shortage of the raining, we get a particular season what we call it as the dry year. Here what happens, one ring represents 1 year of its particular age, and here that particular concept is used for the determination of the age of that one. Here, dendrochronology is one particular subject by which of which we can determine the age of this particular tree. That's all. So here, the thicker, if the ring is thick means, the particular ring belongs to a period which was known as the which has received sufficient rain in that particular region. If the thickness of the ring is thin means in that particular year sufficient rain was not there. That's the beauty associated with this. But for a student of chemistry, this is a real source of inspiration. We are interested only in the chemical part of this. Usually, these rings are formed because of 3 different types of materials. One is hemicellulose, another is cellulose, and other is lignin. Generally, if we combine these 2 terms together, we call the chemical composition of this wood as the lignocellulose material. Lignin is also there. In addition to this, cellulose is also there. How this will be developed? Here, all the biological activities of the planet are depending upon this. All the biological activities of this planet are depending upon one fundamental chemical reaction, what we call it as photosynthesis. All the plants absorb the carbon dioxide from the atmosphere and they absorb the water from the earth and they convert it into glucose. And because of some other reactions, some other sequence of other reactions, this glucose will be converted into lignin, cellulose, and hemicellulose. So actually, what happens in this wood, there will be 38 to 50% of cellulose having the linear structure, which is a polymer, not about this, and 23 to 32% of hemicellulose will be there. The remaining is lignin, which is a very hard material. What happens? The hardness of a particular wood is mainly because of the lignin. Just you compare the newspaper that you are reading in everyday morning with a currency note of 2,000 rupees. You can see the difference between the quality of these two. This is not, it's very simple. So the quality of the currency note is very high because we have to use that note for a period of 1 year, 2 years, 3 years like this. But the time span of one newspaper is just 24 hours. Why? Because we are not separating the lignin content from the wood and directly we are using that, the pulp of the wood for the production of the paper used for the printing of the newspaper. Whereas if you remove almost all the large quantity of lignin from that one, we get a cellulose. We get cellulose, a system consisting of polycellulose, and that can be used for the production of the paper, which can be used in case of the currency, for preparation of currency. That's all. Now, just observe it. After this, after some period, everything will be degraded, and then because of degradation, again the wood enters into the atmosphere. So this represents the composition. In wood, it is based on dry and ashless basis. Means we have dried that one and we have removed all the ash content from that one. So 33% of hemicellulose is that. We call it as cellulose, and 44% of cellulose will be there. The cellulose, the monomer for cellulose is glucose. In total, almost 74 to 75% of cellulose will be there in any wood, and the remaining is lignin. The lignin, the chemical name of lignin is also a polyphenol. That's all. The subject related to the study of lignin is known as polyphenolics. Next one, here, how it is possible to separate the lignin from the remaining part, because in the wood, a hard chemical bond is there, a strong chemical bond is there between the structure of cellulose and lignin. It is very difficult to separate the lignin molecule from the cellulose molecule. But by means of a process, what we call it as sulfonation, we can separate this. So what happens here? Just to observe this. This is the actual structure of the wood. If we treat that one, if we treat the small chips of that wood with the agent, sulfonating agent, then decomposition takes place. The lignin will be separated from the cellulose material. Cellulose will be accumulated there in the form of pulp, and lignin will be transferred into solution. It will be dissolved in a solution. That's a very beautiful one. Remember here, easily we can dissolve or we can separate the lignin from any small piece of wood. I think outside this particular campus, sufficient amount of coconut trees are there. Professor Kuchekar told me that about 500 coconut trees are here. So the outermost shell of that coconut tree, that coconut consists of a sufficient quantity of lignin. In Kannada, we use the word karanta, or in Marathi, I think you are using the word karavanti, is it not? Karavanti, what you are doing is, you are offering the coconut to some temple, and after breaking this, you are throwing it somewhere, is it not? And some people are using that karavanti as a fuel. But remember, my dear friends, it is a rich source of carbon, very rich source of carbon, consisting of about 40% of lignin and about 60% of cellulose. Actually, you can use that karavanti as the source of activated carbon. You can use that one as a source of carbon. You can generate, you can manufacture sufficient quantity of activated charcoal, and you can use it in your chemical laboratory for some other purpose. How? It's very simple one. What is required for the separation of lignin from the cellulose is a simple procedure. If you are having a cooker or autoclave, that's enough actually. What you have to do, you cut the wood or the cement into small pieces, small chips, and then you have to prepare a solution consisting of 20% sodium hydroxide and about 10% of sodium sulfide in water. This particular liquid is having white color. It looks like milk. That's why we call it as the white liquid. Now you mix this liquid with the small chips of karavanti or that kernel, and in a pressure cooker, cook it. It is not a chemical reaction. We call this one as cooking simply. And this particular operation is common in any paper and textile industry. You cook it, means you heat it. You heat it in a pressure cooker at a pressure of 5 to 6 atmosphere, and for a period of about 20 to 25 minutes. That's all. What happens within that period? Breaking of the lignocellulose structure takes place there. Then cellulose will be deposited in the top. It starts to float in the top in the form of pulp, and the lignin enters into the solution media. You will get a beautiful solution of that particular lignin. It's possible. You can use the cellulose for your purpose, or you can use the lignin for some other purpose. What are the different purposes? What are the different operations? What are the different uses of lignin? I will tell you later. And next one, this is the method. Here, what happens? This is the actual structure. This is the structure of lignocellulose. By pre-treatment, you can split it into three components. What is this? Cellulose, hemicellulose, and lignin. Lignin usually it's a soluble material. It's a soluble material in alkaline media. Remember, you are using almost 20% solution of sodium hydroxide. The pH of the solution is around 13 to 14, almost highly alkaline in nature. Lignin is available in the form of dissolved material. How to separate this? It's very simple one. You filter this liquid. The color of the liquid is black. That's why we call the liquid as black liquor. Black liquor. Before the reaction, the color it looks like milk. It's a white liquid. After the dissolution, the color changes to black, and that one is known as black liquor. Then you filter it, adjust the pH to 10 by adding sufficient quantity of water. Then by the addition of hydrochloric acid, or by the addition of sulfuric acid, or by the introduction of carbon dioxide gas, adjust the pH to 2. That means the pH should be acidic. Then what happens? A large quantity of the lignosulfonate will be precipitated out. Large quantity of this lignosulfonate will be precipitated out. You can use this lignosulfonate for your purpose. That's very, very simple one. I will tell the procedure again briefly. You take a small chips of this one. What is this? Any wood or any this carbonator like this. You prepare a solution consisting of 20% sodium hydroxide and almost 10% sodium sulfide. The color is white. In a pressure cooker, cook it for about 20 to 25 or 30 minutes. Then what happens? The splitting of lignosulfonate structure takes place. Lignin enters into the liquid phase, and then the pulp of cellulose is available. You can use it for your purpose, and then by precipitation you can separate the lignin for your purpose. Means just to adjust the pH of the solution to 2, then you will get the precipitation, will the precipitate or the crystals of that one. I will tell you what are lignosulfonates. Very simple one. It's a class of chemical products derived from wood lignin. Need not be wood. You can use, as I told you, you can use any material consisting of originated from the biological source. That's all. And these are the polymers of very high molecular weight. You know the meaning of the molecular weight. Average molecular weight of lignosulfonate is just above 20,000. Average molecular weight. And then the wonderful property associated with this one is the dispersing property. I'll tell you what meaning of this dispersing property again. These are possessing very beautiful adhesive properties, and in almost about 75 to 80% of the lignosulfonates are being used as dispersant binders and organic agglomerates. I will tell you after what are these. Yeah. Now, I'll give you some information about the different applications of lignosulfonates. Okay. Okay. Just observe this. This is the structure of lignin. This is the structure of lignin. You can see different functional groups there. For different functional groups there. OH groups are there. So many functional groups are there. And one more important thing is there about this one. It's a polymer, no doubt about this. But in any polymer, the repeating structure means the repeating monomer have the characteristic properties. Up to 1995, people were thinking that, even the students of chemistry were thinking that the lignin is made up of some repeating unit. But now it has been observed that repeating units are not there not there. It's a lump consisting of so many molecules, and it has three-dimensional structure. This structure is known as telechylic structure, distributed in the space of 3 dimensions, and it is not having a regular structure. But observe this: these three are the common components. These are the common components present in lignin structure. The first one is known as quatercell unit. It's nothing but polyphenol alcohol. Second unit is that it is known as semiphenyl alcohol, and then para-hydroxy phenol unit is also there. Now you try to compare the structure of one or two of these with the vanilla or with the clova oil. You can see some resemblance between the structures, but it is very difficult to split lignin into its monomers when it's of any process because of the presence of ether bond in that one. Okay, so here the sulfonation of lignin usually produces what we call it as lignosulfonate. Okay, this is the composition. Here it is again on dry basis and ashless basis. Usually in wood about 10 to 15% of ash will be there. Here the composition of lignosulfonate solid is represented on dry basis and on ashless basis. So usually 45 to 50% of the lignosulfonate material, means after the precipitation of the lignin, is this one, high molecular weight lignosulfonate, and the average molecular weight of that polymeric structure is 5,000 to 25,000. That's actually the active component of lignosulfonate. Second one, low molecular weight lignosulfonate. About 5 to 10% of that low molecular weight lignosulfonate will be there, and the molecular weight range is just 100 to 5,000. If the molecular weight is very small, then we can call it as oligomer. That's all. And sufficient quantity of oligosaccharides will be also there. The percentage is 3 to 5, and the molecular weight of the oligosaccharide ranges from 500 to 3,000, and sufficient quantity of reducing sugars are also there. That means in some countries, this lignin, means the black liquor produced as a result of that process, is really used as the source of reducing sugars, by means of which you can prepare sufficient quantity of alcohol by the process what's known as fermentation. Reducing sugars percentage is 10 to 15%, and the molecular range is 150 to 180. Some sugar acids will be also there, and small quantity of volatile organic matter is also there, and some rosin and other components, it will be also there. But here, the percentage of the useful lignosulfonate material, that means high molecular lignosulfonate material, is just about 50%. That means if you collect 100 grams of that particular material, only maximum 50%, that means 50 grams of lignosulfonates are available. But it is having one advantage. Most of the lignosulfonate material is being used as adhesives. Sufficient quantity of reducing sugars and sugar acids are also there. Means these are having their own impact on the adhesive property. This can be used directly as organic agglomerates. And if you want to increase the molecular weight of that lignosulfonate, you have to follow a procedure that is known as controlled polymerization. By means of controlled polymerization, you can generate sufficiently large quantity of that one high molecular weight lignosulfonate. Now, I'll give some information about you, the actual applications. Now, in India also, we are using sufficiently large quantity of lignosulfonates. We are having sufficient number of textile industries in our country. We are having sufficient number of paper industries in our country, but unfortunately, we are importing large quantity of lignosulfonate material from the countries like Mexico, South Africa, and Brazil, because we are not using the available resources for the production of the lignosulfonates. So it is having many applications. What are those? I will briefly explain you. First, the most important property associated with lignosulfonate is adhesive property. Adhesive property means it can be used as a binder. It can be used as a binder, and generally lignosulfonates are also known as organic agglomerates. Organic agglomerates. That's very simple one. What happens here? In two different ways, a lignin structure or lignosulfonate structure interacts with a material. By means of physical bond, it can form an agglomerate or a lump. Or by means of the chemical bond formation, it can interact with some other material. For example, especially in the production of plywood, we have to prepare the sheets. In between the sheets, we have to apply some agglomerates. That is it not? Generally, an agglomerate consisting of sufficient quantity of lignosulfonates are being used. Generally, what happens here? Some chemical bond will be formed between the two layers of those sheets, and you will get a strong sheet of the plywood. And here, manufacture of ceramic and refractories, lignosulfonates are having wonderful applications. In Pune University, probably yesterday that person was here, Professor Nikum is his research group is involved in a particular type of research, what they call it as the sleep casting process. It's not sleep casting process. They are interested. Some very good work is going on at Pune University under the guidance of Professor Nikum. What happens here in the production of ceramics and refractories? Initially, we have to prepare a slurry of some certain material, and that particular slurry should possess some beautiful properties. It must slip smoothly in the downward direction, and not only this, after the production, it must be in the position to give you a strong material. So usually, if this particular lignosulfonate material, about up to 4% is added to that particular slurry as some agglomerate, you will get a product of very high quality. You will get a product of very high quality. Again, here the physical bonds are responsible for the stability or the strength of that one. And the second one, usually the animal feed is to be furnished in the form of pellets, especially for the purpose of transportation. We have to prepare the pellets of animal feeds. Then usually if this one lignosulfonate compounds are added with that one, we can prepare some wonderful pellets of very good strength. And here next one, pelletization and briquetization of ground minerals, coal, etc. That's one of the very important one. Here, briquetization, it is actually a word taken from what is this? The cosmology. Cosmology, especially the galaxy of stars, is usually known as briquetizes. That's all. Here, usually after the mining process, we are getting the mineral. If you want to export it to some other country, then it must be furnished. It must be supplied in the form of strong and hard pellets. Then only they will accept it. Then only they will accept it. India is one of the very good exporting country of minerals. They are furnishing the minerals, the ores, to countries like China and others. Especially, this particular mining process is creating so much of problem, especially in Maharashtra state and Karnataka state. Because of that reason, only some politicians are still behind the bars. One person is Janardhan Reddy from Karnataka, and some persons are there in Uttar Pradesh also. Okay, usually for the preparation of the pellets of this one, sufficient quantity of lignosulfonate is to be used. Lignosulfonate is to be used. If lignosulfonate is mixed with the minerals, and you add a small quantity of water, then you prepare the pellets of this. It possesses sufficiently high strength, means it can be transported from one place to other without any difficulty. And then in the manufacture of foundry molding course, a small quantity of lignin is being used because it gives some stability to the molding core. If lignin is not there, there is a possibility of formation of cracks on the cores. To minimize or to avoid the the possibility of the formation of cracks on the molds, we have to use small quantity of lignosulfonates there. And soil stabilization is one of the most important process. Here, we are thinking that all the natural processes are highly efficient in nature, but it's not so. What happens? The natural processes are perfect, no doubt about this, but not efficient. Just to think about this, assume that your body needs few grams of vitamin or some minerals, then you have to supply 100 times more than the required quantity. Means your body has the capacity to absorb a small quantity only small quantity. What happens here? For the soil stabilization to minimize the dust formation and erosion, and even agricultural field, we are mixing small quantity of lignosulfonates with the fertilizers to minimize the wastage of the minerals, and manufacture of light aggregates for civil construction. For example, assume that concrete blocks are required. Concrete blocks are required for the construction of some single structures. Concrete means a material possessing sufficiently high range of plasticity. To make it more and more plastic one, we have to add small quantity of lignosulfonates there, and manufacture of glues, or glue, etc. It is having very wonderful agglomerating property. It can be used as the glue. And the most important field where we are using lignosulfonate is in the field of the production of phenyl formaldehyde and urea formaldehyde resins, especially for adhesives. In plywood industries, large quantity of these metals being used, which gives some high stability and strength to the sheets of plywood. And then another property is that this is known as tensioactive property. Tensioactive property means the property associated with a particular solution when it is dissolved in water. Here, we have to prevent dispersant. We are using dispersant in many fields. Paint is a dispersant. Means it's a suspension of solid and liquid. It's in the language of mechanical engineering, dispersed system means it's a highly complicated system. So many forces are simultaneously acting on a particular system. When a solid is dispersed in a liquid, many forces will be encountered there. First force is gravitational force, which pulls that particle in downward direction in the form of weight. Another one is when it moves in the downward direction, some buoyancy forces will be developed. Viscous forces will be also there. So many forces are simultaneously acting on a particular system, and a stable dispersant means all the forces must be in equilibrium. In addition to this, viscous forces will be also there. Yes, stable means a stable dispersant system means if all the forces are in equilibrium, then that particular system is popularly known as stable system. Now, if most of the salts of lignosulfonate are soluble in water, and most of the dispersants are prepared in water only, aqueous dispersant. What happens if a water sample in which sufficient quantity of lignosulfonate is dissolved is used as dispersing agent? Perfect balance will be established between the solid particles and liquids, and the dispersion system will be a stable system. It will persist for a period of 1 year, 2 years, like this. It means ideal dispersing agent should stabilize this particular system. And in the language of mechanical engineering, this is popularly known as compartmentalization of the system. Compartmentalization, it is a compartment. Compartmentalization means stabilization of a particular system. And in emulsifiers, we are using this one. Emulsifier, one best example of emulsifier is the pesticides which we are supplying to the plant in the form of emulsions. And finally, we are using this as wetting agents. Wetting agents because of the presence of this hydrophilic groups. And I want to tell one more thing. In Brazil, Argentina, and Mexico, football is one of the popular games, is it not? Football. In India, only cricket. In the South American countries, football is dominating. Here, the real enemy for a good sportsperson is the dust formed in the field, is it not? Because the formation of the dust, his efficiency will be reduced. Not only this, some impact is there on his health also. So prevent the dust formation from that particular field. Sufficient quantity of lignosulfonates are being added to the soil. Okay. Then here, tensioactivities, we are using these properties in various fields. First one is oil well drilling dispersants. Oil well drilling dispersant means at the time of the drilling of the well, sufficient amount of heat energy will be liberated because of the friction between the soil and the revolving machine. And what happens, oil means usually petroleum oil. Petroleum oil are highly sensitive to the heat energy. The fire point of petroleum oil is very, very low, means at very low temperature itself, at the temperature of about 60-70 itself, is the possibility of catching fire. To minimize the heat dissipation of the heat at the time of drilling, the dispersant of lignosulfonates are being added. And in India, especially in Assam, we are having some oil wells, and we are importing the lignosulfonates from South American countries for preparation of the dispersant. And then in dispersive dyes, we are using this, and then manufacture of agricultural pesticides. As I told you here, you may be knowing the effect of what's the name of that particular pesticide, which is showing its impact, especially in the coastal area of Maharashtra, endosulfan, is it not? Usually, we are supplying the pesticide in the form of flying mist. Large quantity of this particular pesticide or acaricide enters into the atmosphere, and this released pesticide is having its own impact on the health of the human beings there. Now, to minimize the free release of these active components of the pesticides, we have to add some dispersive or emulsifying agents. And these lignosulfonates are cheap and effective emulsifying agents which can be used here. And then in the carbon black also we can use these. These are the different fields where we can make use of the tensioactive properties associated with the lignosulfonates. Actually, even in the manufacture of slurry explosives, we are using the this one. What is this? The tensioactive properties of lignosulfonates. Then this one of the important property, sequestrants. Actually, the word sequestrant is taken from food chemistry or food technology. Yeah, the meaning is very simple: carrier of metal ions. Carrier of metal ions. These are the lignosulfonates are having very good property. These are very excellent complexing agents. Stable complexes can be manufactured with the help of lignosulfonates. It can be introduced with some food additives, and then lignosulfonates are not a toxic material as trace element carriers in food. We can make use of the sequestrated property. And in welding technology, for the purpose of cleaning of the surface before the welding the surface, we have to clean the surface, and the sequestrated property associated with the lignosulfonate can be used for this purpose. Okay, and then finally, other applications are also there. In tanning industry, especially in Chennai, so many tanning industries are there. The skin processing industries are there. Here, these are having very good capacity to combine with proteins. This property is having very potential application, especially in the field of tanning industries. Tanning industry means the manufacture of leather, is it not? And then from the industrial wastewater, for the removal of some organic materials, we can use the lignosulfonate. And this one of the, as I told you, one of the very important applications. I've already informed you about this one in the previous slide itself. And then the most important application of lignosulfonate is in electrochemical application. In lead acid batteries, a small quantity of lignosulfonate is being added as the organic expander. The meaning is very simple. Usually what happens in lead acid battery, the surface of the lead will be covered by the lead sulfate, is it not? So if the surface is covered by lead sulfate, automatically the efficiency of the lead battery decreases. To maintain the constant cross-section area of the lead surface, we are adding small quantity of lignosulfonate. This particular performance by this one is generally known as what we call it as the organic expander. And believe it or not, in cyclovoltammetry, in our laboratory itself, since we have used the lignosulfonate as one of the small component of electrode, especially in cyclic voltammetry. I think we have studied the basic principle of cyclic voltammetry. Usually, cyclic voltammetry is used for the study of redox behavior of usually organic or inorganic material. Usually, to study the redox behavior of this one. And usually, 3 different electrodes are being used in cyclic voltammetry. First one, the platinum electrode, generally is known as the counter electrode, and calomel electrode is being used. This one is known as the reference electrode. In addition to this, we have to use one more electrode, what we call it as the working electrode. Generally, in cyclic voltammetry, glassy carbon electrode, a carbon paste electrode, or we call it as glassy carbon electrode, or graphene based electrode, or even diamond based electrode are being used for the measurement of the flow rate. I mean, I'll show you the next one. But here we have added small quantity of lignosulfonate with the glassy carbon. Usually, the production of it is very simple. So, if you record the cyclic voltammogram, what happens? Along x-axis, we are plotting the current flow. Along y-axis, we are plotting what is known as the potential. The potential of a particular a compound is the characteristic property of that particular material or functional group. Okay, it's very simple one. We are getting a graph of this. Along x-axis plot the potential, along y-axis plot the current flow. Suddenly what happens at a particular potential, there will be sharp change will be there in the flow rate, and this can be used as the measure of the redox behavior of this one. Usually, this carbon paste electrode is prepared by a procedure. It's a very simple method. 70% of glassy carbon or diamond powder or graphene powder is to be mixed with 30% of silicon oil. And in the bezel and mortar, we have to prepare a paste of this, and at the top of this electrode, we have to pour it like this. It is known as the glassy. What is this? Glassy carbon electrode, paste electrode. That's all. On the other side, we have platinum wire. The change in the potential, the change in the flow rate can be measured as a function of the potential using this electrode. Generally, as I told you, 30% of carbon and 30% of silicon oil and 70% of carbon is being used for the preparation of this carbon paste electrode. But we have added 4% of lignosulfonate with that one. Means we have prepared a carbon paste electrode using 66% glassy carbon, 4% lignosulfonate, and then remaining 30% of silicone oil. And recorded the cyclotomogram of the two different materials. One is dopamine, other is potassium pericyanate. Just to observe it. Here, the first one with the solid line indicates the result that they have obtained as a result of using the glassy carbon electrode. A sharp jump has been observed if 4% of lignosulfonate is being added with that one. This is in case of dopamine, that's in case of pericyanate ion, that's all. So, believe me or not, in a period of just 12 months, we have published 15 papers. And that's also in the journals of impact factor greater than 3 or 3.5. Most of the journals were published by Elsevier, is it not? That's a very, very beautiful one, very beautiful one. And one wonderful opportunities are there in electrochemistry where we can make use of the lignosulfonate as one of the component of the electrode. Automatically, the efficiency increases. At the same time, the resolution power of that one also increases. Now, we are thinking to manufacture one sensor material for the identification of dopamine, especially. Dopamine is having a very high demand, especially in medical science. Okay, this shows the economic aspects. So the rise in the growth of lignosulfonate industries given here, it is continuously increasing. And remember, one of the biggest producer of lignosulfonate in the world is India. But unfortunately, we Indians are using the lignosulfonate as a fuel in paper industry or textile industry for the generation of sufficient quantity of steam. And as a fuel, the efficiency of lignosulfonate is very, very poor. You know that thing very well. Okay. The last one, the influence of various factors on the behavior of lignosulfonate is also given here. Hygroscopicity, foaming, toxicity, influence of the pH on the solution. That's all. The composition, so many things are there. By continuous research, we have to determine this all the parameters. And then finally, one beautiful table is that, and one small mistake is that Na, it is not Na, it must be Na. A should be small. So typographical error is that. This is the mistake committed by our typist. Usually, we are not directly using the lignosulfonate for a particular purpose. Instead of this, we are converting the lignosulfonate into soluble salts of calcium, ammonia, sodium, etc., etc. These are the different fields where the salts of lignosulfonate can be efficiently used for different purposes. Among these, just here, calcium, magnesium salts of lignosulfonates are having very wide range of application. In almost all fields, such as adhesives, etc., this can be used. And then ammonium salts are having limited applications, especially in tanning industry and in plywood industry. And desugared sodium salt and then desugared oxidized sodium salts means sufficient quantity of reducing sugars are also there. It needs to be the consisting of oxidized salts can be used for different purposes. That's all. And I think that you can make use of this information for your future research work. Because wonderful opportunities are available to start your new field of research after the completion of your PG or after the completion of research. Is it not? So, if you any sugar industry or pulp and paper industry or textile industries are available in your area, please establish your contact with them. Try to collect the lignosulfonate liquid, what's known as the black liquid from those. Precipitate it, you will get a beautiful lignosulfonate material. And after purification, you can make use of that one for your purpose. And remember one thing, this particular field of chemistry is just 50 years old. The first PhD in chemistry for this particular field, that's lignosulfonate, was given by University of Helsinki in the year 1963, just 50 years back, it was given. Still, wonderful opportunities are there for you people to start research work. Or if you are having sufficient wood or something in the reason, you collect it in your laboratory itself. You prepare this one. What is this? The lignosulfonate. If you want to have the purest form of lignin, then in the place of craft process, you can use EDTA process also. EDTA, remember, it's an acid. Generally, in chemistry, we are using EDTA for the purpose of preparation of some complexes, but it's an acid for the breaking of the bond between cellulose and this one. We can use EDTA, lignin, we can use EDTA. If you use EDTA process for the production of the lignin, you will get the lignin in purest possible form. You can refer. So many procedures are available by means of which you can manufacture the lignin. Now, and one more process is that that one is known as the periodate process. You will get lignin periodate. Lignin periodate is also available. If you are having a small cooker of capacity 1 liter or 2 liters with some device for the measurement of the pressure, easily you can prepare sufficient quantity of lignin in your laboratory itself. And by controlled polymerization or by means of some controlled chemical reactions, you can modify the structure, and depending upon your requirement, you can use it for your own purpose. You think about this. India, every year, our country is importing large quantity of lignosulfonate from other countries. It is possible to produce large quantity in our different places itself. Okay. Now, I think that this was sufficient for you. I've taken so much of time. So much of your time. I thank the organizers of this particular conference for inviting me to deliver this lecture. So thank you very much. If any doubt or confusion is there in your mind, so please ask me.
Open for discussion. So any clarification or additional information required, please ask.
And remember, not only this lignosulfonates, so many other natural resources are also there. If you go to Ratnagiri district of Maharashtra, what is this? Cashew nut industries are there. One wonderful liquid is available, that is known as cashew nut shell liquid. And the molecule available in that liquid is cardophenol, a phenolic structure associated to connected to one aliphatic molecule. It is having wonderful experience, especially in the National Chemical Laboratory. One person is there, Vadagaonkar is there. He is the excellent, eminent scientist, eminent person, has done a lot of work in that particular field. And if you go to the Goa region, Kokam, that's also available. And we are extracting a butter from that kokum and simply we are exporting it to some other country. And instead of simply exporting the raw material, convert it to some useful material, and then you think about the process of export. So many thousands of such materials are available, especially in India. Okay.
Okay, if there is no any questions.
Thank you, sir, for sharing a great knowledge about decomposition of lignocellulose and its separation and different applications of lignosulfonate. Now moving on towards the next technical session, which is based on synthesis of. May I now request Professor P.N. Bhosle sir to felicitate respected Dr. K.V. Paisel. I request Professor P.N. Bhosle sir to felicitate respected Dr. K.V. Paisel.
So on behalf of all of you,
I again request him to conclude the session.
so Professor Prasanna Kumar Pai delivered his talk on immunosurpluses, right from the manufacturing and the applications and the preparation, simple method of preparation of this immunosurpluses. Even in your laboratory, MSc students can do their project by using the coconut cells and other raw materials, which is easily available in and around this area. So, with this few remarks, the first technical session is complete.
Now, moving on towards the next technical session, which is based on the synthesis of promising hierarchically nanostructural mixed metal, chalconized thin films for photoelectrochemical performance. The chair for this session will be Dr. A.V. Borade sir. I request him to chair the session. Now let us have the pleasure of listening to the honorable and the great speaker, Professor P.N. Bhosle, Head Department of Chemistry, Shivaji University, Kolhapur. Before that, I invite Borade sir to introduce respected Dr. P.N. Bhosle sir.
Introduce.
Good morning, all in one. First, let me welcome and thank who are here. It's a great pleasure for me to introduce from Pravara University, Dr. P.N. Bhosle sir. Actually, he is a professor and head Department of Chemistry of Pravara University. So whatever his biodata is given to me is very stronger and very lengthy. And so I can give even lecture on this biodata. But it's my duty to introduce him in a brief. And I will try to highlight some of the important things now. He is a very strong academically as well as per the administration is concerned. If you see the research activities, around 14 students got his PhD under his chair, and around 4 students they got 4 students they submitted their PhD thesis, and around 4 students they got their PhD now. And if you see his publication, I think he might have completed his century. He published more than 100 papers in the reputed journal, and he presented around more than 120 papers in the reputed conferences and seminars now. One patent is on his credit. If you see his different positions held in the university, he is a member of Senate Shivaji University. At the same time, he is a member of Management Council Shivaji University, and he is the chairman of the following committees: Board of Examination in Applied Chemistry. Again, he is the chairman of the ad hoc board from the Kolhapur University. You will see that from the research point of view, the research grant is very important, and he got number of research grant by the DST, CSIR, UGC, and one grant I found is very creditable, and that is of 2.5 crores is the grant now. Then 11 lakh, 24 lakh, and 10 lakh, 25 lakh, and 28 lakh. So got number of crores of the grant for the research now. So again, there are many things that I can tell you now, but you will understand, sir, by his lecture. Now I will ask you, sir, to deliver his lecture. Okay, thank you, sir.
Kami विचारतो.
Good morning, all of you. My colleague from the Vigilant University, Dr. Mandir, and Pravaranagar. Just the Vasantai, he has delivered the lecture on his universal colleagues. A natural material has the importance in our life. In cultivation, weight is a natural material. I'm also going to talk on the important topic, like that of the air, water, and food material. These three amenities are highly essential to sustain the life on this earth. Along with one more component is highly important. Without this, sustenance of life is impossible. Energy. And energy as such, you know that about 90% energy is extracted from the fossil fuels. And this fossil fuel would be depleted within a few years. And this fossil fuel containing coal, oil, natural gas, these are the, one can call it as a dirty fuel, as it produces tremendous amount of the pollutants in the atmosphere. So whatever the changes going on in the climate, greenhouse effect or the acid rain, or even the depletion of the ozone layer, all are associated with this burning of fossil fuels. Then one must think about the other source of energy, which can be renewed continuously. It should be available easily. We should not produce any type of the pollutants, which is hazardous to the living organisms. So therefore, this topic is I have selected for discussion. Just my biodata was read out by one of the colleagues. So at present, 25 students has got the PhD under my guidance, and 5-6 more. The abstract which is already submitted, and the plan of my presentation is the introduction of the energy technology in the nature's green technology, energy pattern, and the because the importance of the energy. I have to show the introduction. Then the charcoalites and their applications in energy technology. Status of present research in nanostructure charcoalites. Nanostructure charcoalite includes synthesis by chemical route. Binary machinery charcoalite includes applications of charcoalite includes which prospect and the achievements of the major achievements in my level. So introduction to the energy technology. So just I have shared told about the three amenities, air, waters, and the food material. Here, where one abstract the oxygen and sustain the life, which is freely available, plentifully available to sustain the life. The water is essential as a reaction medium. Without water, there is no life. And the third amenity is the food material. Food is essential because whatever the energy chemical energy required for sustainable supply, which can be, one can get different types and carbohydrates, proteins. So all these materials are accepted from the food. Now, realities. We do not have any energy. Is there any progress? Standard of living is closely associated with energy. Without energy, no transportation. Without energy, no food cooking. Without energy, one cannot supply one place to another place. And therefore, the energy has the prime importance in our life. How this energy plays an important role in our life. Just I will introduce some of my primary slides, which gives the introduction to green technology. Why this green technology? Because whatever the activities going on in the environment, naturally, this is nothing but the green technology. 100% utilization of the energy. Very simple photosynthesis, green plants utilize 100% energy, means 100% efficiency. Whatever the radiation given by the sun is fully utilized. However, whatever the technology we have developed to extract the energy, and whatever the energy we extracted is used for example, in case of the cooking of the food, only 52% energy is used. 48% energy is just waste. So likewise, other examples in our day-to-day life where we can't use 100% energy for things. However, the nature as a whole, it can utilize fully the solar radiations million and more years on this planet Earth. Now the introduction to energy technology. Energy technology is defined as an interdisciplinary engineering science having to do with the efficient, safe, environmentally friendly, and economically extraction, conversion, transportation, storage, and use of energy targeted towards yielding high efficiency, difficulty, side effects on human nature and the environment. This is our focus to produce the energy. The energy should not affect the natural environment. The energy should not give any byproducts into the atmosphere which can alter these climatic conditions and all these things. And therefore it is a highly important. So on this basis, I have selected this renewable energy sources for study and for the discussion. Among these, the first is the solar energy. So it has the tremendous potential. One can convert it even the small fraction of the solar radiation into electricity. It can fulfill the energy demands. So this is the first source of the energy that known to the human beings, and might be it will be the last hope of the energy. Because all other energy sources have the limitations, which is exploited day by day, and therefore almost one can depend on the sun, the radiation, the energy which is given out by the sun. And therefore, in many cultures, sun is worshipped as a god. What that exists was born from the sun. And that's why it is the most important source of energy. The second is the wind energy. So which has again the large potential for the extraction of energy. Biomass, then the hydrogen splitting of the water by using the chemical technology. Then the geothermal, whatever the energy which is associated in the underground, and the ocean, tidal, or the biopower, thermal temperature gradient can be used for extraction of energy, and the hydraulic, which has again the limitations. Whatever the dam we have built in India, so every year tremendous amount of the siltation took place, and the water reserve is reducing day by day. So it will create a situation where water resources will be reduced vastly. Therefore, it has again the limitations. Now, the green technology. Green technology is a system that uses innovative methods to create and environmental friendly products. It uses renewable natural resources that never deplete, so future generations can also benefit from it. It can effectively change waste pattern and production in a way that it won't harm the planet Earth. So green technology in general term refers to the growing number of sustainable and non-toxic products and production methods. Examples of the green technology can be found in water purification, cleaning products, food production, and the waste management. That I will show you the statistics of this. But one of the biggest components of the green technology is renewable energy. In the next few pages, we will be exploring this. Now, the branches of green technology. So this green chemistry, green energy, green IT, green building, even the green nanotechnology. So green buildings, yes, almost all the natural lights one can use. Whatever the waste generated can be reused, reduced, or recycled. Even in IT also, because the waste of the e-waste, which creates the tremendous impact on the environment. So we should find the technology that it can be recycled again and again, so that one can save this environment from the toxic pollutants. Now the branches of green technology again one can look about is reduce. First of all, we have to reduce the toxicants which is escaping the environment, which can pollute the air, waters, and the land surface. Otherwise, one can recycle or reuse again and again. Where one can use the atom economy. Every atom can be converted and recycled again and again or in the useful products. Renew the methods, techniques to reduce the toxicants. And after all, one has the responsibility, everybody has the responsibility to reduce the toxicant before it can be escaping into the environment. So the green technology refers to the use of nanotechnology. The environmental sustainability of processes currently producing a negative eternity aim to minimize the potential environmental and human health risks associated with the manufacture and use of nanotechnology products, and to encourage replacement of the existing product with a new nano products that are more environmentally friendly throughout their life cycle. So if we use the nanomaterials in place of the huge material one can use, one can reduce this material so that you can reduce the toxicant which is escaping into the atmosphere. So one can adopt this nanotechnology Now, with this introduction, one can come to the actual fact what is going on in the nature. So, technology converts the primitive unusable material in modern useful material, but technology has a much greater impact on the nature. The impact of it is not significant as that of the automobile. Especially in time, the impact of technology increases along with the progress of civilization. So this, whatever the progress we have done so far, which dates back only 100 to 200 years. The evolution of the Earth, which dates back to about 800 million years. And as far as the age of the Earth is concerned, this modern technology, industrial technology, which is evolved, which completes only 2.5 minutes. So within this short span, we have made tremendous progress by exploiting the nature. And due to this, whatever the climatic changes, the natural calamities which are going on this planet Earth, which dates back with the industrialization. With the advent of the industrialization in 17th, 18th century, we have seen that the industrial growth is the first total economy of any country largely depend on this industrial growth. Industrial growth is must because it is the only way to break the unwanted circle of the poverty. Every country has their own plan for the industrial growth. Industrial growth is must can provide the employment to the vast population of the world. Industrial growth is must because it provides the different devices. Everybody has information of devices and gadgets. And for this, the industrial growth is essential. However, this is the one side of the industrial growth. Other side of the industrial growth, the toxic products, funny waste, which is generated, byproducts, or the toxic gases which is released in the atmosphere, solid waste, which pollute the ground level, and the tremendous amount of water, about 40% water, which is used in industry. 40% water which is used for the irrigation, and only 20% water is available for our drinking purposes, recreational use. So that's why the industry which pollutes the air, water, and the land. However, industrial growth is essential as it provides the products, devices to enhance the standard of living and sustenance of life. So nature as a whole fixes about 110 to 120 billion tons of their carbon dioxide per annum to photosynthesis. We human emit only 0.65 billion tons of carbon dioxide to respiration. But carbon emission due to human activity constitute about 8 billion tons. So because of the burning of the fossil fuels and other materials, which emits other any carbonaceous material, which add the tremendous amount of carbon dioxide in the atmosphere. And it impact on the nature. Carbon dioxide, it is a greenhouse effect. Only the fraction of this carbon dioxide which is used by the plant for the photosynthesis purposes. So it is a clear ultimate efficiency of hydroponic. It achieves only quick travel the nature's way there. 100% carbon dioxide, whatever generated by the plants or living organism, which is utilized by the plants for the photosynthesis. So photosynthesis, where the carbon dioxide, water molecule, and the quantum of energy which gives the chemical energy, synthesis of chemical energy, and this chemical energy becomes the food material to the vast population of the world. So now this short introduction to the. So I want to compare these natural processes with the new processes or the processes developed by the scientists for production of the different materials, useful devices in modern age. Now this is some of the pictures it shows. If we move, we can change the color. It is a nano material. And because of this fluorescent material, we look this as a beautiful. For the example, the Jacob teeth from the smooth surfaces, it can easily run. So because of nano size gears that help them stick to the smooth surfaces using wonderful process. Nature's nanotechnology. Then the second example is again, so a drop of water which is suspended on the leaves, but the leaf is not melted. So this is because the certain leaves have a particular surface structure that makes them difficult to get wet. Water beads into the little droplets due to the nanosized ridges and wax coated here. This phenomenon is called the lotus effect. The next example is the butterfly wings. It has also the. So this happens because the wings are made of nano thin layers that cause the light to reflect differently. So scientists and engineers are using this technology, hopefully, to develop a new type of intelligent solar panel and radiation material. Another example is the shark, how it can run fast in the water. So this you may wonder how shark swims too fast. The various size, shapes, and the texture of the shark skin at the micro and nano levels reduce the drag and make shark very fast in water. Now the another example that dolphins beak. So dolphins have the very large beak for the size of their bodies. The structure at the nano level makes dolphin beaks incredibly light and strong. Engineers and scientists developing similar structures to make stronger, lighter material for the modern devices. Now the energy pattern and the energy conversion. How all these materials are related to my research. Now the energy consumption per capita in the world, among these we have a very low energy consumption per capita as compared to the most developed countries. So tremendous amount of electricity is used. And why they are called the developed countries, it depends upon the energy consumption. So per capita energy consumption in India is very low as compared to the almost all countries in the world. Now the energy pattern conversion solar is by far the most abundant as compared to this circle shows the potential. How much energy potential associated with a particular sector. And this yellow circle is to the sun, which has a tremendous amount of energy. So about 40,000 terawatt years in general. 1 terawatt is 10 power of 12. This much amount of energy which is radiated by the sun just together to the sun. As again this yellow circle, we have the tidal energy ocean energy, which has the only 0.3 potential. Then second is the waves, 0.5 potential. Geothermal, the heat associated underground, is only at the 2%. Then the hydropower, 4, biomass 6, and oceanic 11. Then the wind power 23. Then the natural gas 70, and the petroleum 170. Uranium, that is the atomic power. If you want to use the uranium potential is 220. And the total reserve of this energy is 910 terawatt years, as against 40,000 terawatt years. So these are the energy which is radiated by the sun. If we use this solar photovoltaic model, so 10% efficiency covering 100 into 50 kilometers square in India will generate as much as electricity as produced today in the country. So energy demand of the India today is 250 lakh kilowatts. And if we just cover the area 100 into 50 square meter with the solar panels, it will fulfill the energy demand of India. Now, Indian power sector. So, total expectable potential of the renewable energy is estimated about 200,000 megawatt in India. We have this potential to extract the energy from renewable sources. Among these are the, just we have seen that the wind capacity about 49,000 kilowatt, then the biopower 26,000 kilowatt, and small hydro project about 20,000 kilowatt, and as again this, the solar about 100,000 kilowatts energy potential in India. In India's installed capacity, right now, the energy which is extracted, about 50 to 7% energy which is extracted from the coal. Only the 9% energy which is extracted from the natural gas, and only the 1% energy which is extracted from the hydro, then this hydro 90%, then the nuclear, which are the only 2%, as against the total energy produced in India. Only 2% energy is extracted from the uranium and the fission products. And the other renewable sources, which includes tidal motion, biomass, all other types of the energy, which has the potential only 12%. So we have to reduce this dependence of energy extraction, this coal, because the coal is a dirty fuel. It containing huge amount of the mineral matter, only the sulfur, nitrogen, which get directly converted to their corresponding oxides, and which has a tremendous impact on the environment. So the renewable power sectors we can utilize. So if we see the coal and how it can be reduced by these renewable sources. So with this background, I will come to my usual topic, the synthesis of chalcogenides, metal chalcogenides. So what are chalcogenides? Chalcogenides are nothing but the elements belongs to the 6th group of the periodic classification. That is sulfur, selenium, tellurium. These are called the chalcogens. Why it is called the chalcogens? Because these are the overforming materials. Whatever the materials, either the metals which is present in their crust in the form of oxides, sulfides, selenides or tellurides, and therefore it is called the chalcogens. Now, Metal chalcogenide. So this material range from the common sulfide selenites and tetraids to complex compounds or solid solution systems containing different metal chalcogen elements in various oxidation states. So why this particular metal chalcogen is selected for the study? So they are all semiconductor materials. They have high absorption coefficient. Whatever the light energy which is radiated on the surface of this metal chalcogen, so almost all energy can be converted into electricity. Then the energy matching band gap, it is another important criteria because if the band gap energy, field valence band and the conduction band is separated by 1 or 2 electron volt, and then only it has the large potential to convert the light energy into electricity. And material must be selected having the band gap energy 1 to 2 electron volt. Here, the maximum the conversion efficiency is obtained with the band gap energy 1.5 electron volt having this nickel, and therefore it is one of the important criteria for the fabrication of the solar devices. High degree of thermal, chemical and mechanical stability. Another criteria, it should not be deteriorated or degraded once standing in the atmosphere, because the atmosphere as a whole is containing the different types of pollutants may react with the material and the material will be degraded. So these are the applications of the chalcogenides. It can be used as a gas sensor, it can be used as a photocatalysis, it can be used as a thermoelectrics, it can be used as a supercapacitor, it can be used as lead-ion batteries, it can be used as photoelectrolysis, it can be used as a fuel cells, and it can be used as a solar cells. Now the thin film material, which has the tremendous potential to convert the light energy into the electricity. Among these are the thin film, the low-dimensional material created by condensing one by one molecular atom ion or the species of matter less than about 1 micron. So why the thin film process is selected for this particular study? Because it has high stability, uniformity between the neighboring elements, temperature stability, high precision, long-term stability, high frequency, low noise frequency characteristics, thin and small stable combination, environmental long-term stability against the temperature, and the high stable protection into in the miniaturization and device fabrication. Now we can see that the various devices. So in early stages it was so large, even the computer laptops. Nowadays it is miniaturized because of using these thin materials, which has in the 1 square centimeter area, millions of transistors are embedded, so that the size of the device can be reduced. So that is the thin film. And overall, this is the low cost, because if you use the huge material, it increases the cost of the devices. If you use the material in terms of the nanograms, then automatically the cost of the material will be reduced. So these are the thin film synthesis techniques available in the literature, and among these we have selected the low cost technique, which can be easily fabricated in our laboratory to synthesize the thin film. Various microstructures, one can tailor the band gap, the material within the solar so fraction of energy can be converted. Now these are the characterization technique. To know the properties, whatever the material which we synthesize, whether it is suitable for fabrication of the device or not, it can be checked by characterizing this material using This X-ray fluorescence spectroscopy for the all these materials are the characteristic techniques which are used to know the suitability of the particular material to for the fabrication of the device. Now the technique which we have selected for the synthesis of these thinking materials, so it is a modified chemical synthesis technique as well. The concept precipitation is an hybrid chemical technique of a simple chemical manufacture and controlled chemical growth processes. So the arrested precipitation depends on the Ostwald-Vapouring law, a simple law, and it involves two processes, namely multinucleation and crystal formation. So ion by ion condensation would give the uniform and the structure, perfect structure. So this rate of reaction is controlled to avoid the spontaneous precipitation. For this purpose, suitable complexing agents should be added to arrest metal ions to form the stable complexes. The name given on for this technique, first of all, the suitable complexing agents is for the organic compounds. So organic in inorganic case, the metal ion is bound. This bounded atom ion can be released by altering the pH of the solution so that it can be released, and by ion condensation, one can form the heat film. So this is the simple technique one can fabricate in laboratory for the synthesis of the thin film. So which has the simple low cost, still organize the growth process. Electrical conductivity of the substrate is not the important part. Avoid oxidation or corrosion of the metallic substrate. So pH is so designed, selected the range of the pH. Here, no corrosion or there is no effect of the medium on the formation of the thin film. So these are the characterization process, how to precursor solutions. So we have synthesized the bismuth selenide thin film, so which has a tremendous applications in the sensor technology or photocatalysis, even the thermocooling or the fabrication of the devices, solar devices. So this can be bismuth triethanol amine complex is selected for the synthesis. It has this simple various steps to avoid the reduction of the oxidation state and formation of the characteristic can be achieved by just run the different states at room temperature. But the growth process can be one can from this editing the growth process, how the bismuth triethanol amine complex in presence of sodium, the source of the selenium, sodium selenium sulfide, which is dissociated and which can be converted into sodium sulfate, releasing the selenium at a particular pH, and let the selenium ion react with the bismuth +3 to form the bismuth sulfide. So this ion by ion condensation we can obtain the very uniform thin film on the substrate materials. The reaction mechanism we can present here. The bismuth triethanol amine complex at alkaline pH breaks down and the bismuth plus ion is released. Triethanol amine complex is remains a molecule, and the sodium selenium sulfide, which is again dissociated in alkaline medium to release the selenium 2 plus 2 minus ion, and the condensation of this the bismuth 3 plus and this reagent 2 minus took place, the formation of the molecule Day-2-Session. So this is a again these are the some capping agents. Now the band gap determination, which are again the important task to design the particular material. Whether this band gap matches the maximum span of the solar spectrum or not. It can be judged by taking the absorption spectra of the thin film, and the band gap is determined. So initially the band gap variation is like this at different pH level, and we can select the band gap which shows the maximum absorption coefficient in the solar spectrum, and therefore coloring of this band gap again depends on the various experimental conditions, and these conditions once optimized, one can obtain the large surface area in terms of the inorganic materials. These are the characterization of the material using the X-ray diffraction to know the structure of the material. Then the morphology. Morphology study, scanning electron microscopy, how the structure is modified with the optimized conditions from the nanowires to nanospheres like this. To enlarge the surface area, if we increase the surface area and the surface roughness is again the sufficiently high, then only the electron directing path is created so that the maximum quantum of energy can be converted into the electricity. Then the morphology study XPS, atomic force microscopy study, which gives about the surface roughness of the synthesized material. So these are the composition, whether we have a chemical composition of the material. Day-2-Session, it means the 40% bismuth and the 60% the chalcogen ion. The composition is again the essential task. It can be checked by using this Vidya spectra. And the HPS study also used. Then the second material which we have emphasized is the cadmium zinc selenide in the stoichiometric ratio. These are some of the reaction conditions, and these are this initially material which we have used. The reaction path one can design for the synthesis of the CD-generates in. Again, the complexation of this material metal ions is essential to form the large area and the uniform thinking of the material. Again, the absorption spectrum to know the band gap energy within the range, in the X-ray diffraction, shifting of the time. And the crystalline sizes again plays the important role in the performance of the photovoltaic cell. So these are the microstructures of the CD-generates material. So very beautiful microstructure one can design to changing the condition, reaction condition, and which show the maximum conversion efficiency. So particularly this shows the maximum conversion efficiency as it provides the large surface area to absorb the light energy. Here the ES spectra as well as the experience spectra. So which gives the idea about the composition of the material and the oxidation state of the material. So these are the chemistry where again one can use this as the energy difference between the binding energy So one can judge about what kind of the oxidation state is present in the particular material. So due to the spin orbit coupling, the striking of the genocide must took place here, and one can calculate the binding energy of the particular metal ion. Third material, which is a copper cadmium sulfur shell. So we have started from binary, then the ternary, quaternary, pentanary, and multinary. So the reaction conditions are set in such a way that so all these materials which undergo the condensation to form the very beautiful morphology, which can be beneficial for the maximum conversion efficiency. So all these are the results are published in the international journals. So again, the copper, cadmium, and these are bound with the complexing agent to avoid the precipitation. These are some of the reaction mechanism and the growth mechanism. The color of the film and the uniformity of the film on the copper cadmium superficial layer. These are the calculations to determine the backup energy. UV visible absorption spectra, which will give the idea about the absorption of the energy, in whether it is present in the visible ultraviolet or the higher vision. The X-ray diffraction, which confirm the hexagonal and the stages. So these are the micrograph of the copper cadmium superficial light. So this particular shows the maximum conversion frequency as it provides the large surface area to this cadmium, copper cadmium superficial light. And the nanocrystalline nature is confirmed by taking this high resolution transmission electron micrograph of the image. These images show the formation of the compact and well interconnected nanoparticles to each other. Further, the selected area electron attraction pattern shows good crystalline nature and the formation of distinct ring pattern. Such a bright distinct ring pattern confirms the nanocrystalline nature of the synthesized area. These are the areas spectra again. Know the composition. This is the XPS spectra for the copper cadmium superficial increase. Then the next material is the copper indium cadmium superficial line. See the pentanal material, which we are synthesizing now by using the precursor chemicals. Salts are used for the synthesis. The reaction mechanism, again the complexation. As this method, which is known as arrested precipitation, so first of all we arrest the metal ions by using the selected complexing organic agent, and then the dissociation of this complexing agent at particular pH, which proves our alkaline pH is required to release the metal ions slowly into the solution, and it reacts with the Charpesian ions, and ion by ion condensation, the film is formed on the substrate surface. So that can be the sugar reaction mechanism. The absorption spectra of the pentanary material. So the X-ray diffraction study. The crystallite size and gas judging. So we have monitored the band gap. Band gap is a very important parameter for the fabrication of the any device. And that's why. So we are monitoring the band gap and test the band gap accordingly so that it can show the maximum absorption of the light. These are the microstructures with emission scanning electron microgram. Again, the HRTM morphology which confirm this nature of the thing, lighting. See that in the electrical conductivity. This particular property is required to convert the thermal energy into electricity. This is known as the thermocooling devices. And we have synthesized the material which shows the high figure of merit, which is reported about 0.9, and we have got 0.95, the highest conversion efficiency with this material. Now the applications of this the binary, ternary, quaternary, and quaternary thin films for the conversion of the solar energy. The solar cell is a device which converts solar radiation into electricity. The basic principle of solar cell is the photovoltaic effect, which was first recognized by Vikhe. The ability of material to generate voltage and current under illumination in the solar light falls on the surfaces of the material. The radiation produces the electron hole pairs in the semiconductor, which are separated by voltage. Small potential is required to separate these electron hole pairs. Otherwise, recombination, which do not lose the any electrical current in the external circuit. Then these photogenerated charge carriers then perform work when the solar cell is connected to the load. Now, why solar energy? The applications of solar energy are in general the same as for all renewable energy sources. So it is an unending source of energy. Solar energy has perhaps the largest capacity to meet significant fraction of the future energy needs. Low maintenance, long lasting source of energy, provides cost effective power, non polluting and silent source of the electricity, convenient and flexible sources for low power devices, renewable and sustainable power. It reduces global warming, and overall, our finance minister cannot put any type of tax on this. It will give the subsidy. Okay. So these are the ideal characteristic, IV characteristic of the solar cell. The bandgap energy lies in between 1.1 to 1.7 electron volt, to show the maximum absorption efficiency, and considering the radius available non-toxic materials. Whatever the material which one can use for the fabrication of the solar cell should be non-toxic. Otherwise, it will create other problems. And silicon solar cell in that way, it is a costly, tremendous amount of the steps are required to extract the silicon. Silicon is available in the abundance list. It is about third position. However, the extraction of silicon, pure silicon, is a tremendous difficult task. It creates so many steps, and at every stage, the toxic materials are thrown away in the atmosphere. So one can think about this technology. ESA performance primarily, which is determined on the basis of this IV curve, we should go through this fourth quadrant. Otherwise, the energy efficiency can be calculated from this current voltage characteristic of the material. So the efficiency, so many calculations are required, and finally, this shows the conversion efficiency. It I think photo conversion efficiency of the material. So initially, we have got the only 0.88%, 1.47% conversion efficiency. And whatever the material, the result reported in the literature was containing about 14% conversion efficiency. So it is a sufficient to convert the maximum light energy into the electricity. The second material, copper cadmium sufficient light container material. Copper cadmium material which show the highest conversion efficiency only 0.77%. Then the copper cadmium indium sufficient light, when the indium is added to this material, so it enhance the conversion efficiency. About the 2.4% conversion efficiency is achieved when the indium is added. So quaternary thin film shows the highest conversion efficiency. So these are the bar graph which shows the conversion efficiency percentage. So these are the, some of the material which we have studied in our laboratory. We show the highest conversion efficiency and the performance of the solar cells. So these are the microstructures which is equivalent for the thermocooling conversion of the thermal energy into electricity. The feature prospect to enhance the conversion efficiency, one can follow these steps. In my laboratory, we are following these steps to enhance the conversion efficiency to maximum percentage. So these materials which we have studied so far, last 25 years we are working on this solar. As I have done my PhD in physics and then joined as a lecturer in chemistry, then so that's why I have selected this particular area. So it is the unique example in the Shivaji University, the first case. The man from chemistry has done the PhD in physics and again come to the original well. So that's why we have selected these materials. And primarily we have focused on this fabrication of solar cells, then the thermocooling materials and energy storage materials. So this particular area where the electrochromic materials which we have designed, which can be wrapped on the window glass or the automobile cars. So it can change the color by if you give some potential, 0.2, 0.3 volt potential, then it can change accordingly the daylight. So such materials which we have synthesized, among these are the tungsten oxide, molybdenum oxide, tungsten molybdenum oxide. These are the complementary oxides which has the tremendous potential for the formation of this thermocooling, the electrochromic and the photochromic materials. These are the some of the materials which we have studied so far. And the conversion efficiency, as far as the concern, we have started initially 0 and in 2002, and by the turn of this 2016, we have achieved the highest conversion efficiency 14.21%. These are some of the applications around it. So this work is not possible without the contribution of the math students, which are working in different colleges and different countries, as well as in industries. And these are the research group. So without their contribution, I am unable to discuss any topic, research topic, and their contribution is a major my development. Okay. So finally, you can always depend on sun. When you want energy, tap the sun. This is the good teachers helping and use renewable sources of energy. So this is the message I want to give, and I want to sensitize the younger minds to use these renewable energy sources rather than opting the energy which is extracted from the fossil fuels and everything. Because the fossil fuel is going to last in a few years, and we have to find our own ways to extract the energy. And that's why this is the presentation which is dedicated to sun, because all that exists was born from sun, and therefore, so we are always dependent on sun. Thank you very much.
Thank you, sir, for sharing valuable insights on green technology. May I now request Dr. A.V. Borade, sir, to felicitate respected Dr. P.N. Bhosle, sir.
Now, topic is open for the discussion.
Yeah. First of all, the questions. If you have any doubts, any questions, any clarification, any information, please.
No question, then I will say that this session is over. Yeah, one question is
In spite of advancement in technology, we are not able to utilize this solar energy to that large extent. So, are there any low-cost materials which can reduce the initial cost of solar technology?
So, for this purpose, Government of India has started Pravaranagar Solar National Solar Mission. So, under this, we have proposed the 5-year plan. So, under this technology initiation, so tremendous amount of funds are available to researchers to find out the material, low-cost material, to substitute the silicon solar cell. So many programs are going on.
That's why utilization of solar technology in rural areas especially is not being.
By the turn of 2020, so most of the villages will be done using solar panels. So this is the aim of this Jawaharlal Nehru National Solar Mission.
Thank you.
any question?
Yeah. 4 point. So we have the setup for the determination of the conductivity. Yes,
If no question, then session is over now.
May I now request Dr. A.V. Borade, sir, to felicitate respected Dr. P.N. Bhosle, sir. Borade, sir. I request Borade, sir, to conclude the session. Borade, sir, to conclude the session.
Good afternoon. Sir has given very impressive and
He explained most of the thing in a very simple and lucid language, and especially the topic based on the metal or mixed metal chalcodonite. In his presentation, he explained, or he gave more emphasis on the green chemistry approach, and he especially explained the energy technology and green technology very precisely. Sir, you have given very good information to the newcomers, those who are interested to go in the research for the green chemistry. So this is a very good piece of the research for the young generation. Thank you, sir, for giving a nice lecture.
Thank you, sir. Ladies and gentlemen, this is the time for the meal, and we will gather here after 1 hour for enjoying the next technical session. So before that, enjoy the meal.
एक सेशन खाली चार्जेस आहे रे एक मिनिट
host. तुम्हाला गणपती मजा भेटली जास्त बसा तुमचं जेवण माहिती होतं मला काय खायचं आता खूप चेंज झालेली परिस्थितीत खूप चेंज झाला का लॉक होते का ते पावर काल लॉक होते खाताच नाही काय काय फ्रुट्स खाते फ्रुट्स तर गणपती चल अमूली मॅडम बंद